Hey guys, this week we're going to begin talking about geometry and specifically about classifying shapes. But before we do that, let's talk about this vocabulary. First of all, we have attributes, and that just means a characteristic or feature of a shape. It could be how many sides it has, it could be it's two-dimensional or a 3D shape. Then we have congruent. That means exactly the same. For example, these two triangles here are congruent because they're exactly the same shape. We could also have congruent angles or lines. Then we have parallel. That just means lines that never touch. So if we were to extend these two lines forever, they would never cross each other. Then we have perpendicular. Lines that cross making a right angle. So whenever two lines cross or intersect, they form a right angle right there in the corner. Same thing here. So the angle is 90 degrees. Then we have intersecting lines. It's just lines that cross each other. They don't necessarily form a 90-degree angle. Then we have angle, formed by two lines or rays coming from a common point. So the common point is called a vertex. And so we have one ray going this way and one ray going this way. That forms an angle. Then we have acute angle. An acute angle is an angle that measures less than 90 degrees. An obtuse angle is an angle that measures more than 90 degrees, but less than 180. If it were 180, then it would be a straight line. So you see how the angle is more open here than up here. Then we have a right angle, which measures exactly 90 degrees. It forms a perfect L. Now, in fifth grade, we don't focus on triangles as much, but I do like to review them just because this is something you've covered in third and fourth grade, so you're familiar with this. We have isosceles triangle, and it's an angle that has two sides measuring the same length. And I have a really cool way of remembering isosceles. So I'm going to write the name down, and I'm going to take my L, and I'm going to draw a triangle coming down from the L. Now, if you notice, there's an E here and an E here. There are two letters that are exactly the same. So that tells me that it has two angles and sides that measure the same length. See, this one and this one. Now we have scalene triangle, and that means that all sides measure different lengths. So if I were to write scalene and do the same thing I just did with my L, draw a triangle going down this way, I notice that they're different. This and this are different. Okay, that explains the different lengths. So that's a cool way of remembering isosceles and scalene if you have trouble remembering what each of those mean. And finally, we have equilateral triangle, and that just means all sides measure the same length. Also, the angles are the same as well. Now, how can you recognize a quadrilateral? Well, a quadrilateral is any polygon, and we'll talk about polygons in a minute, any polygon with four sides. Quadrilaterals can be classified by their angles or pair of sides. Okay, so I like to think of a quad, or this quad right here, and it's called a quad because it has four wheels. Now, quadrilateral begins the same way. That means it has four sides. So anything that has four sides is a quadrilateral. Now, these are different types of different quadrilaterals. They each have different characteristics or attributes. And we're going to go over these really quickly. So a parallelogram, for example, both pairs of opposite sides are parallel and equal in length. So if you think of a square slanted to the side, that's what a parallelogram is. So it has two pairs of opposite sides that are parallel. So this one would be parallel to that one, and this one would be parallel to this one. Then we have trapezoid. It says only one pair of parallel sides. This and this are parallel. Now this one isn't parallel with this one because if they were to be extended, they would eventually touch. Then we have rectangle. It says a parallelogram. Remember, it said parallelogram says that it has both pairs of opposite sides that are parallel or equal in length. So if you notice, this one is equal to that one and they're parallel. This one is equal to that one and they're parallel. So a rectangle is a parallelogram with 4 right angles. Notice that it doesn't say anything about its sides. It just says that the angles are right angles. And we'll get to that, back to that in a minute. Then we have rhombus. It says a parallelogram, so it has both pairs of opposite sides are parallel. This one and this one are parallel. This one and this one are parallel. That's why it's considered a parallelogram as well. And it says that all sides measure the same length. So this side is equal to this side, equal to that side, and equal to that side. We can think of it as a square turned on a little, to the right or on its side. And then finally we have square. It says a rectangle. Oh, notice that rectangle over here said that all angles were right angles. So a square must have all right angles if it's saying that a square is a rectangle, right? So a rectangle with all sides the same length. Oh, that was also the definition for rhombus. So a square can also be called a rhombus. Now, just because a square is a rectangle and a square is also a rhombus does not mean a rectangle is a square. Why isn't a rectangle a square? Well, because a square has to have all sides measuring the same length. That's not true. That's not the case for a rectangle. And then a rhombus doesn't necessarily have to have angles that are right angles. Now, think about a kite, for example, or think about a rhombus that's a little elongated or stretched out. It would actually have 2 obtuse angles and 2 acute angles. That is the reason a square cannot be a square is a rhombus, but a rhombus cannot be a square. So let's look at some examples, some problems. It says, which words describe the following shape? Okay, so we're looking at this shape here. And we know, based on what we just learned about these quadrilaterals, that when it has all sides measuring the same length and it forms right angles, we know this is called a square. Now, we can't just choose square because there are other shapes or other descriptions in each option. So, for example, this one says square, but notice that it also says rectangle. Well, can a square be a rectangle? Yes, it can. Can a square be a rhombus? Yes, it can. But this right here is a square. Okay? We can call it a rectangle. We can call it a rhombus. We can't, though, call it a trapezoid. Why? Because a trapezoid would look something like this, and it only has one pair of parallel sides. This one and this one aren't parallel because if we were to extend them, they would eventually cross. So B is not one of my answer choices. Now, because we crossed trapezoid out there, we can also do it here and here, making C and D also not correct options. So our only correct option would be A. The next problem says, which quadrilateral has angles that are always congruent? Now, if we think back to our definitions, the word congruent means exactly the same. So if we're looking for a quadrilateral, we know it's a shape with 4 sides, okay? And if all angles are congruent, that means they have to be the same, okay? Now, there's 2 shapes that come to my mind with angles that are congruent. The rectangle, because all of its angles, and this is in its definition, all angles are 90 degrees or right angles. Also a square, because a square also has all angles measuring 90 degrees or the same. Now, we could say a rectangle and a square, but it only wants one quadrilateral. Otherwise, it would say which quadrilaterals. So are we going to call this shape a rectangle or a square? Well, we should call it a square because remember that a square can also be a rectangle. So if we call it a square, we're covering rectangle also. Let's move on to polygons. A polygon has to be a closed plane figure or a 2D shape, a flat shape, made of line segments. Regular polygons have sides of equal length and angles of equal measure. Irregular polygons do not have sides that are equal in length or angles measuring the same. Now, notice here, I have this regular triangle. This is a regular polygon because all sides and angles measure the same. Now, over here, this one's irregular because they're actually all different sizes, right? Here I have a rectangle, and then this one is not, it's a quadrilateral, but it's not a polygon because the angles and the sides aren't the same. Now, there are other shapes that are considered not polygons. For example, a circle is not a polygon because it is not composed of line segments. And then this shape here, it's like an open hexagon. Not technically, it's not a hexagon because it's not closed completely. And remember, polygons have to be closed plane figures. If they're open like this or have an opening somewhere, then it is not considered a polygon. So let's look at this example. It says Anna's homework asked her to name the shape being described. So the descriptions are, has 4 sides. It may or may not have right angles. It may or may not have equal sides. Has 1 pair of parallel sides. Now, the only 2 descriptions here that give us information to help us figure out what our shape is are those 2. The other 2, it may or may not have right angles. It may or may not have equal sides. Don't really tell us much. So it has 4 sides. So we know it's a quadrilateral. And it says it has 1 pair of parallel sides. Now, it can't be a square or a rectangle because those shapes have 2 pairs of parallel sides. They're parallelograms. So if it only has 1 pair of parallel sides, that only leaves us with one option. It would have to be a trapezoid. Now, a trapezoid is a quadrilateral because it has 4 sides, but it is not a parallelogram because parallelograms have 2 sets of parallel sides. This one only has 1. This side and this side. These sides would eventually cross if we continued them. So the polygon being described on here, on her homework, is a trapezoid. Which polygons have exactly 2 pairs of opposite sides that are parallel? So we're looking for polygons, that means more than one, that have 2 pairs of opposite sides that are parallel. Okay, so our options are rectangle. If we were to draw a rectangle, yes, it is a polygon with 2 pairs of opposite sides. Now this one says triangle and square. A triangle does not have any opposite sides, so we can automatically cross B out and C because it also has triangle in there. And then the last option, D, says a parallelogram and square. Now, there are different shapes considered parallelograms. For example, rectangle or rhombus, they're parallelograms because they have 2 pairs of opposite sides. So that would be an option, and also a square. So we're looking for polygons. A can't be an option because it is not plural. So our best option is D. The next problem says, what word best describes the shapes below? Now, if we look at these shapes and our answer choices, none of them are hexagons because we know that a hexagon has 6 sides and all of these are actually 4-sided shapes, right? So it can't be hexagon. It can't be pentagon because a pentagon, it's a 5-sided shape, you know, the one that looks like a little house. So it can't be a pentagon. And then we have quadrilateral. Isn't that the name for four-sided shapes? So it could be quadrilateral. Or D, rectangle. Well, we know that this is not a rectangle and this is not a rectangle, that's a square. So our best option here would actually be C. All these shapes are four-sided shapes or quadrilaterals. Now, like I mentioned before, in fifth grade, we really don't cover triangles, but I do like to review them just because it is something you covered in third and fourth grade. So triangles can be classified by the length of their sides or by the measure of their angles. A right triangle, for example, always has an angle that measures exactly 90 degrees. An obtuse triangle always has an angle that measures more than 90 degrees, and an acute triangle has all angles measuring less than 90 degrees. Now that's how you classify them based on their angles. You could also classify them based on their sides, and we already talked about this at the beginning of this video when we were reviewing vocabulary. An isosceles triangle always has two sides that measure the same length. A scaling triangle has no sides measuring the same, they're all different lengths. And an equilateral triangle has all sides measuring the same length. Let's look at an example. Now this right here, they're calling it a diagram, which is what it is, but another name for it is also a hierarchy. And we're gonna talk about these a little bit more, specifically with quadrilaterals next week. So the question says, or the problem says, Karina drew the diagram below to show how triangles are different. Using the diagram, determine which statement is true. So A says, a scaling triangle can be obtuse. Well, if we look under scaling, do we see the word obtuse? Yes, we do. So that could be our answer choice, our correct answer choice, but let's read the other ones. B says, a scaling triangle can be an equilateral triangle. So let's look under scaling again. Do we see equilateral? No, we don't, so B can't be an option. C says, an equilateral triangle can be obtuse. So if we look under equilateral, do we see the word obtuse? No, we don't. It can't be C. And D says an isosceles triangle can be equilateral. So if we look under isosceles, do we see the word equilateral? No, we do not. So it can't be D. Our best answer choice would be A.